Here is a very beautiful question from one of our subscribers who wants to understand how do we solve such questions. Very important strategy to learn. In this video, we will see how do we first simplify and then answer the question. Enjoy the journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are sharing with you a brilliant question for our IBHL math students. The question here is sin x times tan x over 1 minus cos x is equal to k. Find the range for the values of k for which the above equation has no solution. You can always pause the video, answer the question, and then look into my suggestions. In case you want to learn directly from us, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top. Let us see what kind of strategy we should be using to solve such a question. Well, step 1 is to simplify the expression on the left so that we can understand what are the restrictions and also what could be the range of values for which k is valid. And from there, we can always find for which range k is not valid. Makes sense? So, as far as the domain is concerned, we can see that the denominator cannot be 0. Means 1 minus cos x is not equal to 0. Means cos x is not equal to 1. And that means x is not equal to 2n pi, correct? Where n belongs to set of integers. So we have one restriction here, and that is, of course, x is not equal to 2n pi, where n belongs to set of integers. Make sense? Now, how do we simplify it? The left hand side given to us is sin x times tan x, and we're dividing by 1 minus cos x. Now, tan x can be written as a ratio of sin x over cos x. We have 1 minus cos x in the denominator. So that gives you sin square x, right? Over cos x comes in the denominator times 1 minus cos x. Now sin square x can be written as 1 minus cos square x, correct? So you see where we are going, right? We can now factor 1 minus cos square x and write it as 1 plus cos x times 1 minus cos x divided by cos x times 1 minus cos x. Makes sense, right? So you can cancel 1 minus cos x and you're left with 1 plus cos x over cos x. So now this expression should help you in finding the solution to the problem, correct? So I hope the first step is absolutely clear. We kind of simplified the left hand side, and if you see, we've written it as 1 plus cos x over cos x, correct? Let's move on to a fresh page continue from there. So, so what we did was that we wrote sin x times tan x over 1 minus cos x as equal to 1 plus cos x divided by cos x. Let me write like this. Is that clear to you, right? Or we can write this as secant x plus 1, correct? So we have an expression that we have the left side equals to secant x plus 1. Now see, secant x is always higher than, greater than plus 1 or is less than minus 1. So that should give you the range what k should be, right? Right. Now as you know that secant x is either greater than equal to 1 or less than equal to minus 1, correct? So there are two values, right? So range could be more than 1 or less than minus 1. Absolute value of secant x is always greater than equal to 1, you can say. So that means if you are looking at secant x plus 1, right, then it means that the range will be what? It could be greater than equal to 1 plus 1, which is 2, right? Or less than equal to minus 1 plus 1, which is 0. Do you see that? So the left side is always greater than equal to 2 or less than equal to 0. Correct? So that gives us our answer, and I hope you can now write the range for the values of k for which the above equation has no solution, right? So if I write k as something which is, let's say now, between 0 means greater than 0 but less than 2. So in that case, the left side will not be having any solution, right? So the range of k is that k is between 0 and 2. Makes sense? So that is how we are going to answer this particular question. I hope the steps are absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.